Hey guys, it's the day before your quiz, so today's lesson will be on your quiz tomorrow. It's going to be over conditions. So we need to review how to check the conditions when you're dealing with means. So let's go ahead and go to page 5 on in your packets that you have, and we'll talk about checking your conditions. So remember we talked about this last unit when I was here with you guys, that to check the conditions for for a confidence interval with means, you had to make sure that you had a random sample and an approximately normal sampling distribution. So remember, to tell whether something is approximately normal or not is sometimes they'll just tell you. They're just going to say, okay, this is approximately normal. So you get to say it's approximately normal because it states that it's approximately normal. So that's awesome. Sometimes they'll tell you the sample size. If your sample size is ever bigger or equal to 30, then you have your sample size large enough to say it's approximately normal. And the last way is to graph your data. Remember, for your data, if you have to graph it, it's going to be a box plot. So we will review how to plot box plots, and you'll look for no outliers and approximately symmetrical in order to say that it is approximately normal. So I'll show you that in today's notes. We'll have an example of each. So let's go ahead and flip the page to page 6 and show you this all in action. We'll also review errors today too, so that will be fun because we haven't done that in a couple of units, and that way you can see what is expected of you as far as errors are concerned. So yesterday we went over the bride's example and the cat's example, and then we added one more about soda, or as I like to say, pop. So we will check the conditions for these problems. We will not calculate or the t-test statistic or the p-value. We're just checking whether or not the conditions have been met. And then we'll talk about errors when they ask about it. So our bride example, yesterday we were talking about are women marrying at a later age. A report stated that in 2000, based on census data, that the mean age of brides marrying for the first time was 25 years. In 2016, a random sample of 100 brides had a mean of 27.5 years with a standard deviation of 5.6 years. They ask you a question, is there sufficient evidence to support the claim that women are married at a later age? We answered that yesterday, okay? But technically, before we answered that, we should have checked that the conditions were met in order to calculate a hypothesis test. So the first condition, you're always going to check that you have a random sample. It literally will always tell you. If it doesn't say random sample, then you don't. If it does, then we do. And that's what I've underlined there. So we're going to say that we have a random sample, and make sure you tell me what it's of. You need a little bit of context. So of brides. You can say of 100 brides, but I just need to know, what do you have a random sample of? Then we need to check for approximately normal. So in this case, they didn't say it was approximately normal, but they did tell us that we had 100 brides. So I will say since n is greater than or equal to 30, the distribution is approximately normal. So if your sample size is ever bigger than or equal to 30, you get to assume an approximately normal distribution. So since we met both conditions, the conditions have been met. So I'll go ahead and say that. So the conditions have been met. Okay, then it asks us about error. So let's review error really quick. So we have a type 1 error and we have a type 2 error. Remember, a type 1 error means that you had sufficient evidence to support HA, but it was really HO. So we'll go ahead and take a couple notes up top just to review this. So type 1 error is evidence for HA, but really HO. And then a type 2 error is when we have insufficient evidence. So insufficient evidence for HA, but really HA. So you didn't find enough evidence for HA, but it really was HA. So just to kind of relate this back to the murder trial, this is saying that you have, so like type 1, says you got enough error to prove or evidence to prove that the person was guilty, but really they weren't guilty. So something went wrong in the evidence that you're gathering. A type 2 error means that you couldn't get enough evidence to prove that that person was guilty, but they're really guilty. You just didn't find the evidence to prove it. Okay, so you do have to remember those two types because they will ask you what potential errors could have made and what type of error is that. So remember, just to flip back, the bride's example. So for the bride's example, we found out that we had sufficient evidence to support the claim that women are marrying at a later age. Okay, so we had sufficient evidence. So since we had sufficient evidence for HA, the type of error we could have made is a type 1 error. So a type 1 error. And what that error could have been is that we have sufficient evidence to support the claim that women are marrying at a later age when really they are marrying at HO, which was 25 years old. So if you flip back to page 5, you guys will see that the HO, so we had evidence for HA that they were later than 25 years old when they married, but really they were 25 when they were marrying. So at a later age when really they are marrying at age 25. So you tell me what type of error, and then you tell me what the potential error was. So you describe it in context. With errors always come consequences. So a consequence of this error could be a number of things. And remember, this isn't just a single answer, okay? You could come up with a lot of different things. For example, when you're older than 25, they may think you're more established so you can afford more. So I'll say prices for wedding services up. They just think that you can afford more now. Could be marketing, like how they market it, wedding stuff, because they're going towards an older clientele. So that could be just a couple. I'll say marketing to older clients. So those aren't the only two, but you do need to think about your type of error that could happen. Or consequences of that error that could happen. Once again, not only one right answer, but just think about what could be an issue with that error if that was made. So let's see on time. So I still have 2 more minutes, so we'll go ahead and start on the next example, and then I'll continue on in the next video. Okay, so now that we talked about error and all that fun stuff, let's go ahead and check the conditions when we're given data. So according to the American Veterinary Medical Association in 2012, American households own 2.1 cats on average. A random sample of 15 households were selected from a veterinarian clinic in a small town, and the number of cats in each household were recorded and stated below. So does this provide evidence that households in this town own fewer cats than the American average? We answered that question yesterday, but once again, we should have checked the conditions first. So first condition, we have a random sample, right? It literally says that. So we have a random sample, and make sure you always tell me of what. So it's of households. You need some context in there. Okay, and that's going to get me pretty close to the time. So in the next video, I'll show you how we check for approximately normal. So see you guys in the next video. Bye.